Hello everybody, this is me, Godo, and I'm gonna be starting a new project for this channel. So I hope that you're gonna join me in this project, and to see if it's a project that you find interesting or not, well, please watch this video and you'll know. So welcome to the presentation. Today, I would like to start by presenting to you what the project is. Then I'm going to go ahead and explain why I'm making this project in the first place. After that, I'm going to go over the how, which is going to be a quick breakdown of the very large steps that I'm going to be taking for this project. And then finally, if you find everything interesting and you make it to the end of the video, we're going to be sharing a very satisfying moment where we're going to be starting symbolically the project. So I hope you bear with me. So first off, what is the project? Well, the project is a keyboard. How is a keyboard a project? Well, I'm going to be making a keyboard from scratch. More precisely, an ergonomic mechanical keyboard. It's going to be a split keyboard as well. So I already kind of started the project a little bit by 3D printing. Whoop. I'm going to show you guys more closely like this. Yes. So I've already 3D printed the case, at least for half of the keyboard. That's right, because there's going to be a second half, which is going to be an exact mirror of that one. And they're going to be connected by here. There's a little hole. There's going to be a little connector that we're going to be able to plug a wire into so that both sides of the keyboards will be able to communicate together. And yeah, this way, the keyboard is ergonomic. What this means, we're going to see very shortly. I'm going to go back to this. Yes. So why? Well, first off, why ergonomic? So an ergonomic keyboard is better for comfort when, for example, programming, especially for people like me who do this professionally and who spend a lot of time using a computer. It's better to have good comfort, doing activities that you do oftentimes. Ergonomy is important, both for your chair, both for your keyboard, both for, everything, your entire work setup. It's also better for long-term health. So if you spend a lot of time like me working on a keyboard, especially on a normal full-size keyboard, such as this one, the keys tend to be, the keys that we use the most tend to be concentrated in a little area. And what happens is, I'm going to show you again the full cam. Maybe it's going to be easier to show. Usually, you're going to have to put your hands like in the middle like this, and maybe your arms go like this, and there's like a little bit of an angle here, which is not a very natural position for the hand. And if you program a lot like this, it's not great for your tendons, and you can get hurt. So if you're able to have a more natural resting position, like if I just put my hands in front of me in a comfortable position, they would be like this. They would kind of be as wide as my shoulders, pretty much, maybe a little less, but a natural position is way closer to the width of the shoulders, and my hands would be kind of there would be no angle between my hands and my arms, right? They would just go in a straight line. The idea with a keyboard like that is that I can, maybe it's better if I show it like this, is that I can, have it, it's difficult to show like this, but basically, the idea is that you really can put your hands in whatever position is comfortable to you, most comfortable to you, and both sides are independent. So there's no reason why you would have to force your hands to be in a less comfortable position. So that's the implications of the ergonomic keyboard. Why do I want it to be mechanical? Very simple, because when I fell into the rabbit hole of ergonomic keyboards and just, keyboards made from scratch, made by, just people, instead of just buying keyboards that are already made. Pretty much all of them are mechanical. I don't even know if it's easy to use a membrane for that, but even if it's possible, while you're customizing, it's kind of fun to have like every key be its own like actual separate button, and also just be able to choose what keys sound good to you, which is what I call the ASMR factor. It's just so much more satisfying to be able to to like choose the feeling of the keys, how they sound, being able to really customize your keyboard. It's really, really fun. Okay, so that's the reasons. I'm just gonna go back to this. That's the reason why I want it to be a mechanical keyboard. So why make it from scratch? I'm making it from scratch for very simple reasons. First off, it allows for a lot more customizability, so I can really do what I want. It also allows for more functionalities, even kind of, I don't know, maybe functionalities that aren't all that useful for most people, but that I just find fun, right? And yeah, again, the fun factor. Oh, also, I didn't write it there, but keyboards that, have are mechanical and ergonomic, they tend to cost a lot. So, by buying the things myself and doing the project from scratch, I do spend a lot of money, like especially for tools and stuff like that, but just the pieces of the keyboard, they end up costing me a lot less. Yes, I have to spend time doing it, but again, it's fun, it's a hobby. So, that's one of the reasons why I'm making it from scratch. Now, how am I going to be doing this? Because, it's all fun and games to have a 3D print and have all the pieces and whatnot, but there's a whole process involved, and it's not easy, right? It's quite complicated. So, largely, right, the steps that I'm going to be taking are going to be, first off, hopefully just one stream is going to be used to solder the switches and just all of the components, I guess, to half of the keyboard. So only the first microcontroller and everything directly connected to it. This way, once I have a half keyboard that is like electrically fully there, fully functional, I can theoretically just have treat it as if it was just a small 20 keys keyboard and just making it function completely, which is what I'm going to do. So I'm going to program the firmware considering only one microcontroller. Then once this is done, at some point, in my free time, I'm going to 3D print the second half of the keyboard. And then I'm probably, we're probably just going to be kind of taking a pause from the firmware and doing a second soldering stream, like super chill, hopefully one stream only again. And then we're going to get back to the firmware to do the 2 microcontroller firmware. The thing is, most of the time, after all, this is a coding project channel. So most of the time is going to be spent programming the firmware, right? It's probably going to take a couple streams every step of the firmware. So the way I'm going to do that is I'm going to break it down just a little bit more. So for one microcontroller firmware, there's a couple steps involved, but it's pretty much about, when I say reading the keys, what I really mean is reading the switches that are, currently being clicked, right? So basically the inputs from the buttons, the key switches are essentially just buttons. So reading the input from the buttons and receiving that in the pins of the microcontroller, then defining a key mapping, evaluating the output, so using the input we're receiving, using the key mapping and evaluating depending on the combination of keys and whatnot. Maybe I can even put in some macros on some keys, if I want to have some actions, recurring actions like, I don't know, Control C, Control V. Control C could be a single key, depending on the layer. Again, layers are a concept. We're going to get into it once we write the firmware. But, there's a whole lot of complexity. But in that complexity, I'm going to be allowed to be very creative. So I'm going to be able to have a very, very customizable, even functionally customizable keyboard, which is really nice. And once I've received all of that, calculated, I guess, all of that information, I can just send it to the computer via USB, and then the computer can just treat that as a a combination of normal key presses to act as if it was a simple normal keyboard. Eventually, we're going to get to the two microcontroller firmware. And really the only thing added on top of, all the logic that's already going to be there for the first microcontroller is going to be the two-way communication, right? Communication for two microcontrollers is not going to be that simple. So basically, there's still going to be one microcontroller connected to the computer, but then the second microcontroller is going to be connected to the first one. The first one is going to be the master microcontroller. The second one is going to be the puppet. It's going to send information to the first microcontroller. First microcontroller can also communicate for, whatever information it needs for synchronization to the puppet. And then the first microcontroller, we're also going to have to add to that firmware by handling the input received from the puppet as well as its own input, and then ordering what's being sent to the computer when, again using USB. So there's going to be a whole lot of orchestration and a lot of wrinkles of complexity in those steps. So this is the how. Now that you know pretty much all of the more like factual overview of the project and what I plan to do with it, we can now spend a satisfying moment by symbolically starting the project, actually. So we're going to be putting the switches in the plate of the keyboard and all of the components that we can put together at this point, and we're going to see what it will look like once it's completed. Of course, we're not going to be soldering anything inside, so all of the pieces are going to be disconnected electrically, but they're going to look from the outside as if it was completed. So let's get right into it, and I hope you enjoy. So let's start with this connector. It's a TRRS connector. So this weird part here, it's something that I designed to be able to put it in and keep it in place in such a way where I can connect and disconnect the TRRS cable without any problems. So it won't move. It's really going to stay in place. So let's put it in. I'm probably going to have to take it back out at some point. Yep. So see, it's there, extremely solid. I can show you that it stays in place very solidly when I put the cable in and out. It's really not even moving whatsoever at all. So extremely solid contraption right there. It's not looking too good, but it's fine because it's inside of the case. Nobody's ever going to see that, and it has its function. One of my goals was that I didn't really want to have to put any screws in or anything like that, so everything's designed to hold in place mechanically by itself. So this is a pretty good start. Now we're going to be putting, I guess, the microcontroller first. Maybe the microcontroller in at the end, actually. We're going to start with the switches. Beautiful, beautiful switches. So I can start right here. Yes, please. You know what? Let's just bring all of the switches here. And the microcontroller. Right there. Whoop, a little bit of dust. Yep. Oh. Yeah, the webcam's autofocus is having a bit of a hard time. Like this. It's beautiful. It's a big moment for me. I've been waiting for this for a long time. Three last ones. I'm almost stressed. Oh boy. And here we go. Last one in. That's beautiful. Okay. Now the microcontroller. It goes in. And on the other side, I'm using these little rows, these little connectors like that. Okay, like that. That's the other half. So on top, you know, we can move. Everything is held in place correctly. So now we can try putting it there. It's going to be a little bit difficult to get everything aligned correctly because there's these little squares where I have to put these columns. And it's pretty hard to see like this. Even without switches, it was kind of difficult. So let's try. They should be aligned somewhat correctly, but it's kind of difficult. Oh, yeah, I think they're going in. Okay. Yep. Like this. I think here and here. Okay. That's pretty good. So now, oh, nope. Wait. There's one here that's not, oh yeah. It clicked in. So that's beautiful. Now I just need to add the keycaps. Let me just check to make sure that I put the right keycap in the right place. Okay. First switch, Z. The Z is going there. Oh, also, while making a custom keyboard, is a D. I am, oh, a little bit I am going to choose to try to use a new keyboard layout. So instead of using the QWERTY keyboard layout, I'm going to be using the Colmac DHM keyboard layout. Looking more and more like a real keyboard. Yep. I really hope you like the sound of my switches. Otherwise, this is gonna be painful to hear. And this should be the last normal letter. And then we go for the special keys. And like this. So the idea is I'm putting my hands like this. And this column, like this column right here, and this column is for the small finger. This finger goes here, this one goes there, and this one uses this column as well as this column. My thumb uses these 3 keys. So that's the idea. And then I'm gonna have to learn the layout by heart so that I don't have to look at it anymore. But everything is held in place correctly. It's, you know, it's pretty solid. And this is what the keyboard is gonna look like from the outside, you know, once it's completed. Of course, we're gonna have to take the plate off and then do the soldering on the first stream. But yeah, that's how it works. And when I want to connect both halves, it's gonna go like this. Ta-da! And there's gonna be 2 halves connected like this. Click. Okay. So, well, that was it. Thank you so much for watching. And I hope you're gonna stick around for the streams. Subscribe to the channel to not miss any of them. I don't really have a schedule. It's whenever I have time and also the energy to do it. But I really hope to put a little boost on that project in the next couple weeks. Hopefully maybe even do the first stream, the first soldering stream, sometime this weekend. So we'll see. Thank you so much, and have a great day.